My name is Adel Gastli. I'm going to present part 2 of the introduction chapter. In this part, we're going to review the main and basic power electronic converters. As I mentioned earlier in the first part of this chapter, when I define power electronics deals with the conversion and control of power from one shape to another shape. So as we know that power exists in two main types as alternating current or DC current, therefore we expect to have mainly four basic types of power electronic converters, which are conversion from AC to DC, AC to AC, DC to DC, and DC to AC. Suppose that I have a DC power supply and I want to feed an AC load, then I will need to convert the DC into AC and thus a DC to AC power electronic converter. Now my DC power supply could provide clean or distorted power, also constant or variable power. My load could be single phase or multi-phase. I may also have to control the load or source current or voltage also. So all these lead to several different topologies of the DC to AC converter. A good example is the house rooftop PV system. We have the PV panels, which are the DC power supply, and the AC loads are the household appliances and the grid. Now, if I have a DC power supply and I want to feed a DC load with a different level of voltage, then I will need to convert DC into DC and use a DC to DC converter. My DC power supply could provide clean or distorted power, also constant or variable DC power. I may also have to control the load or source current or voltage. All these lead to several different topologies of the DC to DC converter. A good example is again the rooftop PV system with battery storage. To charge or discharge the battery, I will need a DC to DC converter. Also, as you know, the PV panels produce variable power with variable voltage and current due to the fluctuation of the solar energy, which is intermittent energy. So, to obtain a constant DC bus voltage and get maximum power from the PV panel at any time, we need to use what we call a maximum power point tracker, which is actually a DC to DC converter. It could be boosting, stepping up the voltage, or stepping down the voltage. Now, if my source is AC but my load needs DC power, then I will have to convert the AC power into a DC power and design an AC to DC converter, or what is also called a rectifier. Again, my AC power could be single or multi-phase, and my DC load power could be constant or variable, which leads to different converters topologies. A good example is the computer power supply. It supplies the computer with a stabilized different DC voltage levels from the AC mains. So it uses AC to DC converters. It may also use DC to DC converters to generate different DC levels. Finally, if my source is AC and my load is also AC, but with different voltage, frequency, and or phase numbers, then I need to have an AC to AC converter. Again, the source power could be single or multi-phases, clean or distorted, with constant or variable voltage, the same for the load power requirements. So we can have several different topologies of the AC-AC converter. A good example is the light dimming system, or what you call light dimmer, which controls the light brightness by varying the AC voltage RMS. Power electronic converters could be single or multi-stage in their topologies. The uninterruptible power supply is a good example of the multi-stage converter, which is cascading several and different converters. Here is the basic topology of an UPS. In normal operation, the load will be fed from the AC main source through a rectifier circuit, which will be also charging batteries And then the DC is converted back to AC, but with what we call the inverter, which is a DC-AC converter, to feed the load with a stabilized voltage. In case of a failure in the main AC power supply, the AC load will continue being fed from the battery through the inverter. UPS are playing nowadays a very significant role in saving lives and money. Lives are saved in hospitals, as you know, in the surgery rooms, which cannot accept power interruption. And money is also saved in banks, which are nowadays fully computerized and cannot afford even a very short power interruption. Otherwise, data could be lost easily during transactions. This is the end of this part. Please join us in the next part, and thank you for listening.